Let's consider applying a force to this car. The car will move over a distance due to this force. We can consider how this force varies with distance. This will result in a graph. Note that the area under the graph gives us the work done by the force. Sometimes the force can vary. Since the work done is the area under the curve, it can be given by an integral. This assumes that the force always acts collinearly with the displacement. There are more complicated definitions of work which we won't get into today. When the force is opposite to the displacement, we get negative work. This just means that the work was done against gravity. By considering how the changes in work and potential energy relate, we can show that the change in work is the negative of the change in potential energy. This only works because our force is opposite to displacement. By considering the change in kinetic energy in this situation, we can see that the change in work is equal to the change in kinetic energy. As the apple falls, it speeds up and gains kinetic energy. The work done is positive, and the change in potential energy is negative. If the apple is lifted, the scenario is the direct opposite. However, we can consider the apple's perspective as well. If the apple falls, the field's work is positive and the apple's work is negative. If the apple rises, the field's work is negative, but the apple's work is positive. We therefore get the following relationships between the change in potential energy and the work done from different perspectives. Note that the work done by the apple is the perspective considered in the A-level specification, but the work done by the field is generally used more often. This will cause confusion if not handled carefully. In this video, we will use the